Hello everyone, this is going to be 8.7, Finding Rational Roots for Algebra 2. Hope you guys are doing well. We're getting these videos out as quickly as we can, taking a little longer than I had initially expected, but I think we're getting into a good groove now, so hopefully they'll be coming out a little faster for you. Today we're going to talk about how you find rational roots for a solution for a polynomial equation. So we're going to be looking at equations like this one, 6x cubed plus 8x squared minus 7x minus 3 equals 0. And we're going to talk about what do you do if you need to solve this without any other information given. So far, when you've been solving these polynomial equations, they've given you at least one solution to get you started. So once you've got that one solution to start, or one root to start, you would do your layer of synthetic division, you would bring it down, solve the new polynomial, or if you had two roots, you would do another layer of synthetic division and solve it from there. But what do we do if they don't give us any roots to get us started, and we have to just come up with a solution by ourselves? Thankfully, there's a theorem to help us. This is called the rational root theorem. Rational root theorem. And for my students, it's on page 382 of your textbook. So I'm just going to read it to you instead of writing it out here for you. But that's where you'll look. The rational root theorem says that suppose a polynomial equation with integral coefficients has the root h over k, where h and k are relatively prime integers. Then h must be a factor of the constant and k must be a factor of the coefficient of the highest degree term. So what we're going to be looking at are factors of the constant and factors of the leading coefficient when it's in descending order. The leading coefficient goes with your highest degree term. That's going to create a list of possible rational solutions. So, possible rational roots. Basically, I'm taking you from an infinite list of possible choices where you don't know what the answer could possibly be, and I'm narrowing it down to this list of possible solutions. This still might be a long list, but it is not as long as an infinite list. So we are giving you a list. They are possible solutions. They will not all work, but they will give you somewhere to start instead of having every possible number you could think of to try. So the way this works is you're going to take the factors of the constant, you're going to put those over the factors of the leading coefficient. And that's going to create a list of fractions. Some of them will end up being integers, you'll see in a second. This list narrows down your choices for you. You're still going to have to do some work and do some guess and check until you get an answer that actually works, but this list is a narrower set of choices than the set of all real numbers. So what we're going to do for this one, our constant is 3. So, well, it's technically -3, but the things that can multiply and give you -3 are +1 and -1, and +3 and -3. So those are going to go on top. The list of possible factors for your leading coefficient, that's 6. 6 has factors of 1, 2, 3, and 6. So 1, 2, 3, 6. All right, so that's going to make a list. Plus or minus 1 over 1 and 3 over 1. Then we're going to go to the next one, plus or minus 1 over 2 and 3 over 2. Then we're going to go to the next one, plus or minus 1 over 3 and 3 over 3. But 3 over 3 is 1. 1 is already in our list. So we've got 1 over 3, plus or minus. And then we've got 1 over 6 or 3 over 6. 3 over 6 is 1/2, which is already in our list. So 1 over 6. So that's 1, 2, 3, 4, 5, 6 positives, but it's also 6 negatives. So this is technically 12 possible rational roots. Now, key thing here, these are possible. They are not all truly going to be roots. But we went from having an infinite list of real numbers to choose from down to 12 numbers to choose from. This is giving us a starting point. So that's how you make a list of your possible rational solutions. Sometimes they're just going to ask you to list the possible rational solutions. This is all you have to do. Make this list. Now, the next thing I'm going to show you is what do you do with that list once you have it? Why are we making a list? You might be asking yourself. That's what I'm going to show you now. So we can use this list of possible rational roots to actually solve an equation. So I'm going to give you a new equation to work with. So new example, we're going to use 4x to the 4th plus 3x squared minus 1 equals 0. We want to solve this guy. This is a 4th degree polynomial. So we're going to look at how can you solve this 4th degree polynomial using synthetic division. Well, we need some roots to try in our synthetic division. So we're going to make a list of possible rational solutions. So possible rational roots. So we always take the constant on top. So the constant here is 1. 1 is just 1 times 1. Then we take the list of the factors of the leading coefficient. That's 4. 4 could be 1 times 4 or 2 times 2. So 1, 2, 4. Those are all plus minus. All right, so if we make that list, we're going to have 1 over 1, 1 over 2, and 1 over 4. So that's what we're going to try. Now we're going to take this list. This is 1, 2, 3 positives, but also 3 negatives. So this is 6 possible solutions. Now I'm just going to start trying them. I'm going to try positive 1. I'm going to do synthetic division. I'm going to look to see if I have a 0 remainder. If I do, yay! If I don't, I'm going to go back and try the next thing on the list. So we're going to start with 1. I'm going to do synthetic division. So I've got 4th power. There's no 3rd power, so I'm going to need a placeholder. 2nd power, there's no 1st power, so I'm going to need a placeholder. So I've got to the 4th, to the 3rd, to the 2nd, to the 1st, and then my constant. 2 placeholders for that one. All right, I'm going to bring down, multiply, add, multiply, add, multiply, add, multiply, add. Uh-oh. I want this to be a 0 remainder, and it's not. So this one is a no. Positive 1 is not a root of this equation. So I took 1 off the list. Now I'm going to try negative 1. It's a good thing we're really good at synthetic division by now because we're going to be doing it a lot here. All right, try it again. Bring down, multiply, add, multiply, add, and so on and so forth and what have you. Oh, that one does not give me a 0 remainder either. That's okay. We're going to keep going. Next on the list would be positive 1/2. I'm going to try that. Positive 1/2. Same coefficient row because I haven't found a solution yet. Feeling lucky with this one. Half of 4 is 2. Then we add. Half of 2 is 1. We add. Half of 4 is 2. Half of 2 is 1. And there we go. Yes! All right, we got a 0 remainder. So when we get a 0 remainder, that means that 1/2 is a root to this equation. 1/2 is a root. Now, because this was a 4th degree equation, we've done one layer of synthetic division. We brought it down to a cubic equation. We would like to get it down to a squared equation because we know how to solve quadratics. So we're going to keep going through the list until we find another root that works. I'm going to use my new adjusted coefficient row so I can bring it down to a quadratic function. So I'm going to try the next thing on the list, which is -1/2, and just see what happens. Just because +1/2 is a solution does not necessarily mean that -1/2 will automatically be a solution. We still have to test it. So I've got -1/2. I'm trying it with my new coefficient row because now I have it down to a cubed function. I want to bring it down one more to a squared function. So I've got 4, 2, 4, 2. Here we go. Bring down. 1/2 of 4 is 2, but this is negative. Then we have 0. 1/2 of 4 is 2, but this is negative. That one also worked. Again, not necessarily going to always happen that the positive and negative are going to both be solutions, but in this case they are. So now I've taken this down to a squared function, so now I can finish solving it. So I have 4x squared plus 0x plus 4 equals 0. You have a couple options here. You can factor out the 4 and then divide it and solve, or I can subtract 4 from both sides, divide by 4, so I have x squared equals -1. Take the square root of both sides. We learned that the definition of the square root of -1 is I. And when you take the square root of something to solve, you always have a positive and a negative answer. So this is going to be plus or minus I. All right, so this was a 4th degree equation. And I do have 4 solutions. +1/2 worked, -1/2 worked, and then when I solved it, I got positive I and negative I. So my roots or solutions are 1/2, -1/2, I, and negative I. So that's how you use a list of possible solutions to solve. There was some work involved where we had some that we tried and they didn't work, but we just kept going down our list until we found one that worked. Okay. So let's look at one more. Same thing, we're going to make the possible list and then we're going to start trying them until we can solve. All right, so for our next equation, we're going to use 2x cubed minus 5x squared plus 6x minus 2 equals 0. So our first step is going to be to list the possible rational solutions or roots. So if we make a list of possibles, remember you start with your constant. Start with your constant. What can multiply and give you -2? Well, you could have -1 and +2 or +1 and -2. So that gives you plus or minus 1 and plus or minus 2. Then underneath that you do factors of your leading coefficient, which is also 2. So that's also going to be plus or minus 1, plus or minus 2. So our list is going to be 1 over 1, 2 over 1, and then 1 over 2, and then 2 over 2. 2 over 2 is 1, and that's already in our list. Okay, so we've got 1, 2, 3 positive, 1, 2, 3 negative. So 6 possible rational solutions to start with. All right, so I just like to start at the beginning. I'm going to start with +1. So I'm going to put 1 in here, and then I'm going to make my coefficient row 2, -5, 6, -2. All right, bring down, multiply, add, multiply, add, multiply, add. Does not give me a 0 remainder, so this one is not a root. Okay, next in the list would be -1, so we could try -1, 2, -5, 6, -2. Bring down, multiply, add, multiply, add, multiply, add. also does not give us a remainder of 0, so that one's also not a solution. It is possible for positive 1 to not work, but negative 1 to work. So I don't want you to think that just because the positive 1 does or doesn't work, doesn't mean the negative solution is going to give you the same outcome. Don't get that in your head. All right, for the sake of time, I can see into the future, so I know that positive 1/2 is going to be a solution because I've worked this out already. So I'm going to skip over trying positive 2 and negative 2, and I'm going to skip to positive 1/2. All right, so we've got our coefficient row, and we're going to bring down half of 2 is 1, then we add half of negative 4 is negative 2, and then we add half of 4 is 2, and then we add. All right, so I knew ahead of time that that one was going to be a solution. So we started with a 3rd degree function. So with just one layer of synthetic division, we brought this one down to a quadratic. So we have 2x squared minus 4x plus 4 equals 0. Maybe you're noticing right away that it has a GCF, so we can factor out a GCF of 2. X squared minus 2x plus 2 equals 0. Divide both sides by 2, and it ends up canceling out. So we have x squared minus 2x plus 2 equals 0. You could try to factor this, but there's not a factor of positive 2 that could break down and add up to negative 2, so we're going to have to go quadratic on this one. So x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. Good review of the quadratic formula for you. Our leading coefficient is our a value. This is our b value. There's our c value. So we've got the opposite of b, negative 2. The opposite of that would be positive 2. Plus or minus the square root of b squared. So negative 2 squared minus 4 times a times c all over 2 times a. Okay? Negative 2 squared is positive 4. Negative 4 times 1 times 2 is negative 8. That's all over 2. 4 minus 8 is negative 4 over 2. We know that the square root of 4 is 2, and we know that the square root of negative 1 is I. So this is 2 plus or minus 2i all over 2. On the top, you can factor out a 2, and that allows you to reduce. So our final answer here, 1 plus or minus I. So cubic equation should have 3 answers. We have one answer here, positive 1/2. That was one of our roots because it gave us a 0 remainder. And then here's 2 answers, 1 plus I, and then 1 minus I. So 3 answers, 3rd degree function, we have all of our roots. All right, just remember when you're doing the assignment, read the directions carefully. For part of the assignment, it just says to list the possible rational roots. That means you're just making this list right here. That's all you have to do for those. So if it's just asking you for a list, you can make the list and then stop. If it's asking you to solve, you're going to make your list, and then you have to start working your way through the list until you get one that gives you a 0 remainder. Then you have to work it out and solve it from there. So read the directions. If you only need a list, make a list. If you're going to solve, you're going to do the whole thing. If you have any questions, you can send an email to my school email address. That's the official form of communication if you want to be able to ask me questions or anything like that. So it should be on the email list that you got from the school. My office hours are Mondays and Wednesdays from 10 to 12. So that's when I'll next be checking my email. Send me those questions. I'm happy to help, and I hope you're doing well. I miss you guys.